Hello everyone, welcome to STEM with Chantel.
I'm Chantel, and this is Ty.
Hi, welcome to the Aviation Museum of Kentucky. My name is Lincoln Kilgore. Today, we're partnering with the Jessamine County Public Library to bring you this program. Now, by now, you've probably seen the PowerPoint Magic of Flight, which discusses the four forces of flight. And today, here at the museum, we're going to use our mini historic aircraft to illustrate to you those four forces of flight. And here at the museum, we have so many amazing aircraft. From the very first aircraft to fly in Kentucky back in 1908, all the way to supersonic military jets. Now, to begin our discussion, we're going to talk about weight, because all aircraft, as do all objects on Earth, have weight. And some light airplanes weigh just 700 to 800 pounds, while the huge F-14 Tomcat here weighs 40,000 pounds empty and can lift over 70,000 pounds on its own. Now, as we know, aircraft's weight is directly proportional to its size or its mass. So we can see here from this massive jet all the way to this tiny home-built aircraft. Now, in order for an aircraft to move through the air, it has to produce thrust. Now, thrust comes from your engine, and the engine turns a propeller which helps to push the aircraft through the air. Now, the propeller is shaped so it takes a big bite out of the air and forces it back, much like your ceiling fan at home. But a lot of modern aircraft today are powered by jet engines. In a jet engine, jet fuel is ignited and put through a series of fans which compress it and push out of the back of the exhaust, which propels the jet forward. Now, jet engines are capable of much faster speeds and flying much higher than propeller-driven aircraft. Now, the massive Boeing 747 used 4 of these gigantic engines to propel it through the air. This engine was capable of lifting hundreds of passengers, thousands of gallons of fuel, and the entire aircraft up and pushing it forward at hundreds of miles per hour. Now, the smaller guy that we saw here earlier, this jet engine served on multiple military aircraft. Now, the large F-4 Phantom, our magnificent Blue Angels A-4 Skyhawk, and our United States Air Force Thunderbird's T-38 Talon were all propelled using jet engines. Now, no matter if the aircraft is propeller-driven or jet-driven, when enough thrust is produced and enough speed is acquired, the aircraft eventually produces enough lift that it will eventually take off. As you saw in the PowerPoint, lift is generated by air flowing over the top of the wing. Now, do you remember the demonstration of Bernoulli's principle using the piece of paper? Let's do it again. I take my piece of paper, and notice as I blow over the top, the paper actually lifts up to meet that lower pressure of air flowing over top of it. Now, some of our smaller, slower aircraft need a much larger wing area to produce lift. Let's go take a look at some of those wings. Now, some earlier aircraft actually used 2 wings and were called biplanes. Now, notice between the wings all these different struts and wires. We'll be talking about that a bit later. Now, as we pan around and show you all of our different aircraft, notice how a lot of the wings are much wider, much thicker than what you've seen before. Yes, the aircraft flew at slower speeds, but they produced so much more lift and could operate out of such smaller airports. Now, let's go look at our jets again. Now, notice the wings of our A-4 Skyhawk here. They're a lot shorter and not super thick. You can tell this plane is fast just by looking at it. But look, the wing of the T-38 Talon is actually a lot shorter and a lot thinner than our friend the A-4 Skyhawk. This aircraft needs a lot of speed to generate lift, and actually can fly faster than the speed of sound. That's called supersonic flight. Our friend the F-4 Phantom and the F-14 Tomcat are also supersonic aircraft. Now, the F-14 actually has a really neat trick that allows it to both take off from carriers and fly faster than 1,000 miles per hour. The wing of the F-14 actually sweeps back as it goes faster. So far, we've talked about the weight of an aircraft, the thrust that pushes it through the air, and the lift that lets it fly. That's just 3 of the 4 forces. So what is the 4th? Just as standing out in a strong wind creates a force on you, moving through the air creates a force on the moving object. This force is called drag. Now, just as lift must overcome weight for an aircraft to fly, thrust must overcome drag for it to move fast enough to maintain flight. Now, as we've been talking about the 4 forces of flight, you can see here all the way back to the very first ever aircraft, the Wright Flyer, to now, all aircraft have that smooth, sleek, aerodynamic shape to them. But with older aircraft, you see these struts and wires and landing gear and all this junk just sitting out from them. that produces a lot of drag, which makes it a very slow, inefficient aircraft. Now, as aircraft advance all the way up to our jets, we have retractable landing gear, single wings, and a whole lot more power. Don't they just look fast sitting there? So to summarize, lift and thrust must overcome drag and weight in order to produce flight. Now, a glider, or a sailplane, is an aircraft that does not have an engine on it. It has no means of creating thrust, so how does it fly? This is accomplished in one of two ways. The most common way is to pull the glider into the air with an airplane. A long rope is attached to both aircraft, and the airplane provides the thrust for both of them. Now, once the glider is high enough, it can be released from the airplane. It can then use gravity to provide thrust by flying downward. Or it can find the rising air that happens on warm days and fly upwards in what is called a thermal. Now, if you've ever watched a hawk or a buzzard soaring in a circle without flapping its wings, you've seen a thermal at work. Now, one interesting thing about these sailplanes is their long, narrow wings. These wings provide maximum lift with minimum drag and weight, which is how sailplanes can actually fly several hours and cover hundreds of miles without an engine. Now, another different type of flying machine is the helicopter. If you look at the helicopter, there are no wings jutting out of the side, so how does it fly? Well, if you look up at the rotors are actually narrow wings that make the helicopter fly. The engine turns gears, which turn the rotors, which produce enough lift that eventually the helicopter will fly. Well, that concludes our lesson over the four forces of flight. The next time that you see an airplane flying, remember, you know what's going on. And that goes for everything in the sky. From a little sparrow to a flock of geese to a majestic eagle, you know what is keeping that up there. And I also want to invite you all to the Aviation Museum of Kentucky here at Bluegrass Airport in Lexington. I especially want to invite you guys to the Aviation Museum summer camps held in June. For more information, visit us online at www.aviationky.org. I'm Lincoln Kilgore. Thank you guys so much for spending some time with me. Have a great future and happy flying.
Thanks for watching. If you would like to see more STEM with Chantel videos, check out this playlist. If you want to know when JCPL puts out more content, click the subscribe button and the notification bell.